Hi everyone and welcome to this full stack machine learning course, and this is lecture number 1. So in this video we're going to talk about machine learning fundamentals. Maybe this video will be a little bit long because I had talked all about you need to know in fundamentals. Okay, so this is a Jupyter notebook in front of you. So what you have to do, you have to just sit on any table and just watch this video, and if you are on a system or a computer, just open that notebook. The link will be in the description down box below, and the notebook will be in a PDF form. Okay, so you have to code along the way. Okay, but in this lecture we are not going to code anything. We are only going to talk about fundamentals, and then in the next video we'll be learning algorithms. Okay, so in this video what I recommend is to check out the notes. The PDF forum will be given to you, and the Jupyter notebook will be also a download link will be given to you. Okay, so no need to worry, but I recommend you to check out that PDF forum. Okay, and just follow me along. Okay, so let's take a look at what are the overview. So in this lecture we'll be studying about actually what a machine learning is. Then we'll talk about how machine learning system works. Okay, then we'll talk about some of the types of machine learning systems, and that includes a supervised learning, unsupervised learning, and a reinforcement learning. Okay, so we'll talk in detail, and then we'll talk about main challenges you face in machine learning and how do we solve that. Not just now, we'll say to the problem actually what are the main challenges of machine learning. Then we'll divide our data. We'll talk about overfitting, underfitting, and development set, or we can say the cross validation set. Okay, so let's talk about what is machine learning. So so just think about by your own. Just think about. I will ask you to just think about little bit about that. What is machine learning? As the name suggests, machines that learns. And from where it learns? It learns from the data. So from the previous data, let me take out my epic pen. What do you mean by machine learning? As you can say that machines that learns from the previous data, and make predictions on what it has learned, it's called machine learning. Okay, so let's say this is my data. Okay, previous data. Let's say the stocks means the stocks data, or house price prediction means we are given the prices of the house. Basis on the size of the house. Okay, so we are given size and the price, and we have to train it on an algorithm and we have got a model, and then we can use this model to make predictions. Okay, so this is what an overview we'll talk about in detail just in a second. So what you can think of the machine learning as the machines that learns from the data and make intelligent predictions on what it has learned without being explicitly programmed. Okay, so let's talk about this term, explicitly programmed. What do you mean by this? Just search on the internet about the same. Okay, so I think you have searched. So let's talk about what is explicitly programmed. Means, yeah, let's say there is a cloth. Let's say pant. There a t-shirt, and if we got an image which is equals to pant or a t-shirt, then we can say this is a pant or a t-shirt. But we have to write a lot of code, and this does not make sense using an if and else condition. So this does not make sense. So that's why we have an algorithm which we train according to that. Okay, so in the next video we'll be starting talking about algorithms. Okay, so this is what a machine learning is. Let's take a look at some of the slightly more good definition of machine learning. First of all, let's talk about the Arthur Samuel. So machine learning is the field of study that gives computers or machines, okay, or machines the ability to learn without being explicitly programmed. Again, the explicitly programmed means the same. Okay, so it is the field of computer science that gives computers the ability to learn without being explicitly programmed. And then we have another definition, which is a more engineering type definition. A computer program is said to learn from the experience E. A computer program is said to learn from the experience E with respect to some class of a task T and some performance measured by P. If its performance on T as measured by P improves the experience E. So you might be saying, hey Ayush, I'm a little bit, not a little, you are very confused about it. So let's take an example. That's an example of playing checkers, okay? So let me write playing checkers. Yeah, playing checkers. So this is our example. Okay, so here let's fit this example onto this definition. A computer program is said to learn from the experience A. In this case, what is E means experience? Means the machine, how much the machine has played. Okay, so how much the machine has played. What is the task here? Task is the playing checkers. Task is the playing checkers. What is the performance? It checks whether the computer will win the next game or not. So the probability, okay? It's a probability. If he failed, then he improves himself and learns from the experience because he failed. And if the machine won, then it learned from the experience about how actually I won. So all the data, it learns from the experience. So on which its task is doing, okay? So now it makes a good definition. Okay, so machine learning has taken place in every domain of industry, like a business, education, film industry, or healthcare. We'll talk about later on in this detail about the business domains. So let's talk about some of the applications of machine learning. So some of the applications of machine learning are, there we have a self-driving cars, robotics, real estate, in healthcare, in business, and all those kind of stuffs. Okay, so in self-driving cars, we make use of machine learning, deep learning, artificial intelligence to make cars to learn to drive themselves. And then we have in robotics, it simply means the machine learning is highly used in that. And we have a real estate. And real estate means we are predicting the price of the house, on the basis of some parameters, some features. Okay, so we'll talk, you will see as we go further about the applications of machine learning. Okay, how it works, how machine learning works. Okay, so how it works. And first of all, what we do, we study the problem. What we do, we study the problem. Let's say our problem is predict the price of the house, Okay, so we have to predict the price of the house based on which? The size of the house. Means we will be given the size and you have to predict the price. Okay, so these are called the features. Okay, so these are called the features. Means on the basis of feature size, we have to predict the target variable. What we want to predict, so the thing that we want to predict is called a target variable or a feature, we can say. Okay, a variable, feature, column is all our equivalent. Okay, so if you have any kind of problem till now, comment down below. Just comment down below. I'll be happy. I'll be responding you within 2 hours. Okay, and the form will be in the description down box below. Just go there, ask any kind of questions. I will be happy to assist you. I'll be making sure that I'll be contacting you via Gmail if you found that if I found that your question is a little bit genuine. Okay, and otherwise you can simply follow comment me in the description down box below, or head over to LinkedIn or Instagram to ask me the queries. Okay, the link will in the description down box below. Okay, so what we are going to do, we are on the basis of the size of the house, this is called a feature. Based on the feature of size of the house, we will predict the target variable, which is the price of the house. Again, I'm saying the target variable are the variable which we want to predict, or the feature that we want to predict, and feature variable are all columns. Okay, so we study the problem, we study the problem, we train the algorithm. Let's say we have choose a linear regression, and again you might be very uncomfortable just now because you have not heard till now. Let's say any algorithm, okay, that help us to achieve this goal, and we evaluate it. We check if our model is good or not. If it is good, we will deploy it. If it is not, we will analyze the error and then we'll proceed further. Okay, we fix the error and then we will proceed further. So in this way, the machine learning works, a workflow works. Okay. Okay, so now you can go and drink your water. I'm just coming up after this video. Okay, so how many types of machine learning systems? As machine learning problems is classified into supervised learning, supervised learning, unsupervised learning, and a reinforcement learning. Okay, so what do you mean by supervised learning? Supervised learning, let's take I'm going to first take an example. Let's take an example. Again, the price of the house. You have to predict the price of the house. Price of the house basis on the size of the house. Okay, so you will be given the size and you want to predict the price. Okay, pretty much clear what I'm trying to say you here. Okay, so on the basis of the size, we are going to predict the price of the house. Okay, so you can see here that the size and price have some kind of relationship, because of the house, you can see here that there is a relationship. There is a relationship between the price and the size. So what we give input is called the X, and what we get output is called the Y. So again, I'm written here, input value is equals to X and the output value Y, and there is a relationship between X and Y, means the input value and the output value in supervised learning. So the size of the house is some kind of relationship between the price of the house. I think you are getting me. Okay. So what we do, we have a label data. What do you mean by label data? This label data means that we have a label data, like we know that what our output should look like. Means how I can demonstrate in let's say we have a size and we want to predict the price. So we have a label things, means the size is labeled, means we have a clear goal that what we want to predict. We want to predict the price of the house, so it's a label. So if we have a clear goal, we know what our output should look like. So we have a clear goal that we want to predict the price of the house. Okay, so let's take one more example. So let's say we want to classify a image as a cat or a non-cat. Okay, so we will be given an image. We want to classify and this image as a cat or a non-cat. So there is we will give input image, and we will give input which is X. X we denote usually a big X, a capital X, and then we get the output which is the cat or a non-cat. Okay, which is a Y, small y. Okay, so we give input and you can see this is labeled, means we have clear goal what our output should look like, means we know what our output should look like. Either it will be cat or non-cat. Okay, so we usually denote as a positive and let's keep it aside. We will be getting a discrete value. We'll be getting a discrete value, either cat or a non-cat, means two possibilities. Either the image will be cat or a non-cat. Yeah, so this is the classification problem. This is the classification problem. It simply means what I'm trying to say here, that if our output if our output has a discrete value. That in supervised learning, we know what our output should look like. I mean, in the previous example, in house prediction, we know our output will be the price. And in classification, we know what our output should look like, the either cat or a non-cat. So either cat or a non-cat. So it has two possibilities, 0 or 1. So let's denote a 0 as a cat and 1 as a non-cat. Okay, so there are two possibilities. So the output is discrete value. The output is discrete value, means either 1 or 2, either cat or non-cat. So this is called a discrete value. If you wanted to know more about the discrete value, kindly comment down below. Okay, and in the previous example, we have said we have taken a look at the price of the house. We want to predict the price. So the price of the house, well, it can be $5,000. It can be $10,000. It can be $50,000. It is a continuous. So it's a regression problem. It's a regression problem. So we can divide our supervised learning problem into regression and classification. Regression for continuous data and classification for categorical data. Okay, so let's see some examples. For regression, we have an example of predicting the price of the house, or we can say the stock price prediction. It is also continued because our output is a price of the stock. Okay, and in email classification as a spam or a non-spam or a cat image classification and all those kind of stuffs are classification tasks. Okay, so now I think that you got a decent idea about supervised learning. So now let's take a look at unsupervised learning. Okay? Okay, so in unsupervised learning, let's say this is our x, and this is, we have to, on the basis of x, we have to predict the price. Okay? So we'll be given an input value and we have to predict the output value. In this, we feed the data, the algorithms in which the data are not labeled, or we can say that we don't know what our output should look like. Let's take an example that we have a t-shirt, and we have to classify this t-shirt. We have to classify this t-shirt into M, L, and XL. So we can either take this, and this as M, L, and XL. So we can say that we don't know what our output should look like, and there is not any kind of relationship between our input value and the output value, which is X and the Y. Either we don't know what our output should look like. We don't know what our output should look like. We only know that we want to classify this as a cat, sorry, not a cat, L, M, XL. So we have to make a cluster of the data. And we have to recognize the cluster, and then we have to make prediction based upon that. Okay, so you will see, we will talk in more detail later on. So if you have not understood unsupervised learning, so don't worry about it. One line for this is the data are not labeled, or we can say there is not any kind of relationship between input value X and output value Y, or we can say that we don't know what our output should look like. Okay. Okay, and some examples of t-shirt sizing, anomaly detection, recommendation systems, or we can say a lot more examples we'll see later on. Okay, so the third type we have a reinforcement learning, which is the out of the boundary course, but we can take a look at just for a small simplicity that you have a decent idea about what is a reinforcement learning. So let's take one example. Let's take an example of a baby. It's 2 years old. A baby. What he touches the hot jar or a hot glass. He feels hurt and he cries. It was his first time, and in second time he will not touch that. So what happens? That the baby touches the hot jar, he cried, he feel hurt, he cried, he feel hurt, and then it was the first time he get the punishment, I think so, because it touched the hot jar and he cried, means he get the punishment. And there was a second time he see, but he did not touch that jar, so he did not feel hurt and he get reward. So we can relate this as a machine learning also. We can relate this. So what this reinforcement learning, this is our agent. This is a pretty good agent, and if it touches the, I think heat or this lava, it will get it's minus 50 points, or it will go with this, it will get a reward. It will get the reward. So what it does, it observes, select action using policy, it does the action, it gets penalty or a reward, and it update the policy if it is done wrong, and it waits until it is found. Okay, so what it does, it checks, it observes what to touch. If it touches this, he will get penalty. If it touches this, he will get reward. And then if it touches this, he will learn that, oh, I'm going to touch from the next time. I'm going to avoid, I'm going to put this water onto that. So he will learn, he will update himself. So this is called a reinforcement learning. Rewards and penalty based systems. Okay, so some of the notations that you should be familiar with. Again, the y is often called the target variable, which we want to predict, and the x is the input variable, which we give input and y we get. Okay, so I've already taught you. Okay, so what are the main challenges in machine learning? So what we do, we get the data, feed the data to the algorithm, and after the algorithm gets the data, he makes predictions. But the main thing is that how do we get this data? There's a lot more problems on this data. So how do we overcome that? So what are the main challenges? That we have an insufficient quantity of a training data. What does that mean of a training data? We'll talk more in just detail. Poor quality data. It means we have missing values, non-values, and all those kind of stuffs. Irrelevant feature. Irrelevant feature means we have a very kind of less important feature. Like I have taken an example of a simple example, but for predicting the price of the house, there's a lot more features like a crime rate, population, then we have bedrooms in the bedrooms or fans. 81 features, I think so. 1,000 features is required for predicting the price of the house effectively. So we have to neglect or we have to drop the features because if they are less important. So we have 3 techniques: feature selection, feature extraction, and feature creating new features. We'll talk more about it in detail when we do the project. Okay. Okay. So we divide our data. So let's say we have our data, this one. Okay, so we have this our data, and what we do, how we can test our model. So we have trained the model. So how we can test the model? We have trained the model in whole training data. So if we make predictions, we're using the model on this training data, we will get 100%. Means the model is 100% accurate. But the thing is that this model is learned from this data and is making predictions on this data. Means we are given the size and the price both. We are given the size and the price, and we are training the data onto this. We want new examples, but it is predicting on this example, on these examples, so it will give no 100%. We have to give new examples, and we have to check whether this model is accurate or not. So for that, we have what we do. First of all, we divide our data into 2 sets: training sets and testing sets. So we train our model using the training sets, and we'll leave our model we'll leave the test set for testing the model later on after we launch our models. Okay, so what we do, we divide the data, means I think 70%, 30%, or we can say 80%, 20% according to your needs. So 80% of our whole data for training and 20% of our whole data for testing. Okay, so that's why we divide our data. So we want to test our model, so we divide our data and check, and we know, and you can see here that if this is our whole data, size and the price. So on the basis we divide the data, and we use the training data for training the things and use the testing data for testing the model. Okay, so let's say we train the model using the whole training data, okay. So we train the model onto the training data, and what it does means we have trained the model on the training data, and let's say our model gives 100% accuracy onto the training data. It says that your model is 100% accurate, and but in new examples, if we give a testing set, it says it performs a very bad onto the testing set or a new examples. So this is called the overfitting of the training data. So let's take a look at the definition. It means that a model performs well onto the training data, but it does not generalize well onto the testing set or new examples. Okay, so solution of the training data is to gather more data, to take out more data, to reduce the noise in our data. It means Gaussian noise, and to use a regularization. Mainly we do this. Okay, we'll talk more about a detail later on. So how do we think about it that our model is just right or it is overfitting? So if this is our training examples, and if our model is this, it means it is good. And if our model touches every means he performs very well on our training set, but this is the example of overfitting. Okay, so what about underfitting? In underfitting, our model does not perform well on our training set as well as on the testing set. It simply means that we train our model onto this. Onto this training data, and it does not perform well onto the training set. As if it is not learned well on training set, so how does it perform well on a testing set? So it's obvious that it means the model performs badly on the training data. So it's obvious that it will perform badly on the testing set. So this is the underfitted. Let's see this. If our model is something like this, it would be perfect. But this is a straight line, which is a very high cost function. So it's underfitted. It usually occurs when you have a low data, when you have a low amount of data, when you have less important features, when we have one feature only. So it happens in that case. Good and fit robust, and then we have an overfitted model. Okay. So let's talk about one last topic, which is cross validation set. So let's take an example. Let's say you want to go from A to point B. There will be many modes of transport. You can go with a bus, you can go with a train, you can go with a flight, you can go with a bicycle, any kind of modes of transport. But the one you choose, the more efficient the modes of transport in that situation. So what we do in machine learning and cross validation set, we simply hold out some part of a training set to evaluate onto different models. It simply means that we hold this data, means among this data, we hold this data and we train different algorithms onto this data. Means we train a linear regression, random forest, decision trees, support vector machine, different algorithms onto this data, and we check if what model perform well. So if this linear regression perform best, so we'll use this. So we use different thing, and at last we choose the one who performs the best. Okay, so the notebook will be in the description down box below, and I hope that you really enjoyed this session, this 30-minute session. Okay, so that's it for this video. And again, before leaving that, I like to ask that please do subscribe this YouTube channel, do follow me on Instagram and LinkedIn, and if you have any kind of problem, please ask me. If you have a serious problem, just ask me in the forum below, or if you have queries like that, ask me in comment down below, or just ask me on LinkedIn, okay, or Instagram. Okay, so that's it for this video. I'll be catching on the next video. Till then, bye bye.